Hello and welcome to another Ginge Mathematician video. Today this is an all of iGCSE Maths paper 6 and we're doing the investigation on the paper, so the very first question. I haven't done a paper 6 for a long time, so it's nice to get stuck in. This is one from 2018. 1 hour 30 minutes, so we've got 45 minutes to do the investigation. Right, so our investigation, so questions 1 to 4 here, we're going to be estimating pi using the Monte Carlo method essentially. And again, we're going to spend no more than 45 minutes. One thing that we need to know, so previous knowledge, is that the area of a circle is equal to pi r squared. So we need to know that formula to be able to answer the questions. Now Lee, he draws circles on rectangular pieces of paper. Nice hobby to have. And he drops grains of rice at random onto the pieces of paper. And then he counts the number of grains of rice inside each circle. Let's look at a visual representation of this. So Lee here, he draws a circle of radius 5 centimeters on a rectangular piece of paper measuring 40 centimeters by 20 centimeters. So they give us the diagram here below, and the probability P that a grain of rice lands inside the circle, so key language they always put in bold here, so inside the circle, so in the circle, is equal to the area of the circle divided by the area of the paper. And our first task here is to show that P for this particular piece of paper is approximately 0.098. So we're just going to need to do some substitution here. First of all, the area of the circle, we have that formula pi r squared. In this case, the radius of our circle is equal to 5. So we just substitute that in for the numerator of the fraction, pi times 5 squared. The area of the paper, so the area of a rectangle is length times width. So in this case, we have 40 times 20 or 20 times 40. That goes in the denominator, the bottom of the fraction. And then we can just simplify this down. So 5 squared is equal to 25. 25 times pi is 25 pi. And down the bottom, we have 40 times 20. That's equal to 800. Remember, on this paper, you do have a calculator. So I would, at this point, type in 25 pi divided by 800. That gives me then 0.098174. And again, we've seen then is approximately equal to 0.098. Notice these older papers, this is from 2018, do not have the number of marks allocated for each question, but the more modern papers do. On to question 2 here. So Lee drops 10 grains of rice, again, key information, we underline it, at random onto the piece of paper. The diagram shows the result. So these little things here are grains of rice. The relative frequency, remember this phrase, so we can also say experimental probability, that means essentially the same thing. And the relative frequency that a grain of rice is dropped inside the circle is calculated by the number of grains of rice in the circle divided by the total number of grains of rice dropped. So if we want to find the relative frequency here, we want to write our fraction, the number of grains inside the circle, so we have 2 grains in here. How many grains do we have in total? We underline this key information, we have 10, so our fraction is equal to 2 over 10, which is fine for 1 mark, or you can also write it as 1 over 5. Now Lee gets a bit more ambitious and drops 10 more grains of rice, so notice we now have 20 grains in total at random on the piece of paper, and we need to show the relative frequency that a grain of rice is inside the circle is 0.15. So if we use the same formula from before, how many do we have inside the circle? We have 3. How many in total? Well, we now have 20 pieces of rice here, so our probability will be 3 over 20, and that can be written as 0.15. Now the relative frequency that a grain of rice is inside the circle gives an estimate, hence the word relative frequency, for the probability P. Now the area of the circle that we're working with here, so this one here, is 25 times pi, so pi times 5 squared. And now we're going to use both these ideas together to get an estimate of pi is 4.8. This is where students then start finding this paper quite tricky. So first of all, we start with the area of the circle. We're told that, so I just substitute that in, 25 times pi. The area of the paper, we worked this out in the first part. That was equal here to 800. So we just pop in 800, like so. And this is equal to 0.15. So all we need to do at this particular point is make pi the subject. We want pi equal something. So we have a divide by 800. What's the opposite of dividing by 800? Timesing by 800 on both sides. This cancels, giving us 25 times pi, or 25 pi, and that's equal to 0.15 divided by 800. See, multiplied by 800. Okay, you've got to be careful what you're doing as you go through these steps. So 0.15 times 800. And now we want to find pi on its own. So what's the opposite of timesing by 25? We're going to divide by 25 on both sides. This cancels, giving us just pi. And now we have 0.15 times 800 over 25. Only at this point do I rush to my calculator and work this out. So we have 0.15 times 800, divide that by 25, and we get the exact answer here, which we want, of 4.8. The key thing in this paper, particularly paper 6, is working backwards and forwards through the paper. Sometimes you'll need knowledge from a previous part of the question. That's really, really important. So now on to part B. This time Lee draws a circle of radius 10 centimeters on a rectangular piece of paper, and the piece of paper has changed. It's now 30 centimeters by 20 centimeters. And now we need to complete this statement with a number. So the area of the circle, remember our formula pi r squared. This time our r is equal to 10. So we're going to have pi times 10 squared. Notice, read the question carefully. We need to complete the statement with a number. 10 squared, strictly speaking, is not a number. So we need to work out what 10 squared is. And 10 times 10 is equal to 100. So the area of the circle is equal to 100 times pi. Now Lee dropped 10 grains of rice at random on the piece of paper, and notice we now get 4 pieces of grain inside the circle, and then Lee removes the 10 grains of rice and does the experiment again, and then we see how many are in the circle this time. So we have 1, 2, 3, 4, 5, 6 on the second attempt, and now we need to fill in our table. So on the first attempt we had 4 inside the circle, and on B attempt we had 6 inside the circle. So the combined result for all 20 grains of rice, well, we had 4 and 6, so then we get equal to 10. Notice the relative frequency makes a lot of sense here, because we have 10 grains of rice and we've dropped 20 in total. 10 from trial A and 10 from trial B. Now we're going to use that formula that we've seen before to estimate pi using the combined results for all 20 grains of rice. So the area of the circle, again going back and forward through the paper, is equal to 100 times pi. The area of the paper, if we go back, 30 times 20, so the length times width, and that's equal to the relative frequency. Notice that's given here as 10 over 20. And we can just copy that in straight away. At this point, we just need to simplify everything down here. So 100 times pi, that's equal to 100 pi. 30 times 20 is 600. Now 10 over 20 is the same as 1 over 2. And now we do the same process as before, working our way through to get pi the subject. So what's the opposite of dividing by 600? We're going to times by 600 on both sides. This cancels, giving us 100 pi. There we are. A half times 600, that's equal to 300. And now we want pi on its own. So what's the opposite of timesing by 100? Well, we want to divide by 100 on both sides. This cancels, giving us pi, and then we do 300 divided by 100. That gives us our estimate for pi, which is not too far away, of equal to 3. So pi is equal to 3. Okay, so you can see the first part of the mark scheme. You'll see these things called C opportunity. This does not exist anymore in the more modern papers. They just give you the full marks as you go through. Before they used to give you extra marks of communication, but that doesn't happen anymore. Notice CAO, it's an important thing to realize, correct answer only, which means if you wrote 10 squared rather than 100, you would lose that particular mark. Okay, and on to question 2. If you're liking this content so far, then please do think about liking and subscribing if you want more iGCSE maths content just like this. So, question 2a here. Lee draws a circle of radius 12 centimeters on a different piece of paper. The circle touches all 4 edges of the paper. So notice we actually have a square here, which is useful to notice here, because if this is 12, well, this will also be 12. Because they're both radiuses of the circle, and this also works going upwards and downwards as well. So we essentially end up here with a square where each length here is 24 centimeters, 12 plus 12 being 24. So good to know this as we go through the question. Now Lee drops 50 grains of rice at random on the paper. He removes that 50 grains, he drops them again onto the piece of paper. So we had 50 grains of rice, we have another 50 grains of rice, and the combined number of grains inside the circle is 78 out of the 100 that was used in total. Use the formula area of circle over area of paper equals relative frequency to estimate pi. So notice our relative frequency, we have 78 out of 100. So 78 out of 100, we can write that as 0.78. And that's going to be our relative frequency. The area of the circle, well, again, we're using that formula, A equals pi r squared. So the area of the circle will be pi times 12 squared. 12 times 12 is 144. The area of the paper, this is why we needed to know it was a square, because we have 24 here and 24 here. So the area of this will be 24 times 24, and then this is all equal to 0.78. Once we have that written down, we go through the same process that we did before. So first of all, on both sides, the opposite of dividing by 24 times 24 is timesing by 24 twice. This will allow this to be cancelled, giving us pi times 144 is equal to 0.78 times 24 times 24, or 24 squared. And then finally, what's the opposite of timesing by 144? Well, we want to divide by 144 on both sides. This cancels, giving us pi. And now we have a calculation we can put into the calculator. 0.78 times 24 times 24. With that, all over 144. Again, at this point, this is where the calculator really comes in handy. So, got 0.78 times 24 times 24 divided by 144. In this case, we get the value of 3.12. Nice, we're getting very, very close to pi. And we'll see as we go through this, our approximation gets better and better using this Monte Carlo method. Part B here. Now this time Lee draws a circle of radius r, so we're not told what the radius is, and the circle touches all 4 edges of the paper. Show that for any value of r, the estimate for pi is equal to k times relative frequency, where k is an integer, a whole number. So we do this in exactly the same way, and this is an important technique to have on this paper. You approach it in the same way you've seen before, but then more algebra comes involved. First of all, we've still got r going across here, and r down here, and r here. So in this case, the length of our square is going to be r plus r, which is 2r, and then the height will be r plus r, which is 2r. Now we use the formula like we used before. So the area of the circle divided by the area of the paper is equal to the relative frequency. I'll use RF to represent this. Notice we don't need to work that out, but we do need to work out the other two things. Now the area of the circle, that's just going to be pi r squared, our original formula. The area of the paper here, well, it's going to be 2r times 2r. So the area of the square is length times height. And we can simplify that down. 2 times 2 is 4. R times r is r squared. So we get a 4r squared at the bottom, and that's equal to relative frequency. Notice we've got a great opportunity here to simplify. We have r squared top and bottom, so we can cancel. That leaves us then with pi over 4 is equal to the relative frequency. And now we want pi on its own. So we times by 4 on both sides. This cancels, giving us pi is equal to 4 lots of, or 4 times the relative frequency. So our k here, our integer, whole number, is equal to 4. So you can have a look through the mark scheme and see where you pick up the method marks and the key accuracy mark at the end. Okay, so we're going to go away from squares and we're going to look towards hexagons, specifically a regular hexagon. That means that all sides are the same, all angles are also the same. So that's what regular means here. And again, hexagon is a 6-sided shape and the circle touches all 6 edges of the paper. Okay. Lee drops grains of rice at random on the paper and counts the number of grains of rice inside the circle and finds the relative frequency as before. Okay, and we need to find an estimate for the value of pi when x is 30, and the relative frequency we were told is 0.905. We're using that magic formula again and again here. So what I would do here is actually draw a separate diagram just so we can see this a bit more clearly, and we have this inscribed circle which goes in. Again, I'll do my best to draw a half decent diagram like so. Now notice we've got x is 30, so if we substitute that in here, we have root 3 over 2 times 30. That simplifies. 30 divided by 2 is 15, so the height of this will be 15 root 3, and that's also our radius. And then along here, that's going to be 30 centimeters as well. Okay, so first of all, the area of the circle, again, we can use that formula again and again, pi r squared. So in this case, the area of the circle will just be pi times the radius, which is 15 root 3 all squared. The area of the paper is a bit trickier, the area of a hexagon, but because it's regular, notice we can actually divide this shape into 6 triangles that are exactly the same. So I'll just drop this in. So if we work out one of these triangles, then we can just multiply them by 6 to work out the area of the entire hexagon. So if we take this triangle down here, so let's zoom in on that triangle. So we have the perpendicular height being 15 root 3. We have the entire base here being 30 centimeters. So the area of this triangle is going to be base times height. So 15 root 3 times 30 divided by 2. Again, we can simplify this down. So 30 divided by 2 is 15. So we get 15 root 3 times 15. Again, you can use your calculator at any point here. Don't need to do this mentally. And again, if we times these things together, it'll simplify it down because 15 times 15 is equal to 225 root 3. However, we do have 6 of these triangles. So the area of this, that's just the area of one triangle. So we need to multiply that by 6 to get the area of the entire paper. So we just take the 225, times that by 6. So we get 1,350 root 3 at the bottom. Notice I'm keeping things at surds. It's going to make our life a bit easier later on. Now we're told that the relative frequency here is equal to 0.905. At this point, all we need to do is rearrange, like we've done before, to get pi the subject. Again, I'll speed through this part. So we're going to times by the bottom here and then divide by the top. So pi is equal to 0.905 times 1350 root 3 divided by 15 root 3 squared. In exactly the same process we've done questions 1 and 2. At this point, we just use our calculator. So we've got 0.905 times 1350 root 3. And then we're going to divide by 15 root 3 all squared. That's going to give us, I'm very close to pi. So we get 3.13501 ... Generally around to 2 decimal places. So we get 3.14 to 2 decimal places. Get our final answer there. Okay, and on to question B, which is a more generalized version of what we just done. So for any value of x, we want to find the estimate, and k in this case is an exact constant. Really important because that means we need to be working with surds. We can't just use decimal approximations. We do this in exactly the same way. So first of all, we ignore that we've actually got the value of 30. We just treat it the same way. But first of all, we have root 3 over 2x as our radius. So the top part of our formula will be pi times root 3 over 2x all squared. Notice the parallels with what we've done before. So we just use pi r squared here and replace the r with root 3 over 2x. Now we need to do the tricky part, which is working out the areas of the triangles in terms of x. So let's do this separately again. This time we're just going to be using x. So x at the bottom, we have root 3 over 2x here. And we want to work out the area of one triangle, which is the two things multiplied together, so x times root 3 over 2x. And then we divide by 2. We can simplify this down slightly. So x times x is x squared, so we get root 3 over 2 x squared divided by 2. If we divide by 2 twice, that's the same as divide by 4. So we get root 3 over 4x squared. However, we want all the triangles added together, so we need to multiply that by 6. So we want to do root 3 over 4x squared multiplied by 6. So we try and simplify as much as we can as we go along. So if we do that, we then get cancellation here. So 2 goes into here twice, here 3 times. So the area of paper will equal, let's tidy this up, 3 root 3 over 2x squared. That is our expression for the bottom. So we get 3 root 3 over 2x squared. And that's equal to the relative frequency. Now we just need to tidy this up. So the first thing I'm going to do is just square this out. So if we times this by itself, root 3 over 2 times root 3 over 2. So we get root 3 times root 3 is 3. 2 times 2 is 4. And then don't forget what the x squared there. And we have what we had at the bottom here. It gets messy with these harder questions towards the end of the paper. The great thing is now we actually just have an x squared top and bottom, so we can just simplify through. Then we're going to multiply by the denominator. So we're going to multiply by 3 root 2 over 2 on both sides. This cancels, giving us then pi times 3/4 is equal to 3 root 3 over 2 times the relative frequency. And finally, we want the pi on its own, so the opposite of timesing by 3/4 is dividing by 3/4 on both sides. This cancels, giving us pi equals 3 root 3 over 2 divided by 3/4 and then multiplied by the relative frequency. Now we just have to know our fraction skills here. So if I just take this part and simplify this, because this is going to be our k essentially from this formula. So we're going to have 3 root 3 over 2. Dividing fractions, keep it, switch it, flip it. So we're going to switch this to a times, flip this, and do a bit of simplification. This cancels, and we finally get just 2 root 3 as our answer for k. Tricky question, but again, all you need to do here is just go through it nice and carefully, nice and steadily, and take your time. You get more than enough time to do these complicated algebraic expressions. Okay, there's the mark scheme, so you can see 2 root 3. The mark scheme seems so innocent compared to what we've done so far. And on to question 4. So Lee draws a circle on a piece of paper in the shape of a regular polygon with n sides. So notice we had an hexagon which had 6 sides. Now we're increasing the number of sides. So like a 10-sided shape or a 20-sided shape. The circle touches all n edges of the paper. He drops grains of rice at random onto the piece of paper and counts the number of grains inside the circle and finds the relative frequency. Explain clearly why the constant k gives an approximation on its own for pi as the value of n increases. So imagine you had like a 20-sided shape. So a 20-sided shape, you're getting sides just move around. Again, doing a very bad impression of this, but you can see there are sides, but it's actually looking more and more circular. So if you put a circle within this, most of this is actually going to be inside the circle. So as you increase the number of sides here, essentially it's going to become like a circle. So when you put the rice into the circle, most of it's going to fall in the center. Notice in our previous question, we had the relative frequency as 0.905. What's going to happen here is the relative frequency, so the RF, is going to head towards 1 as the number of sides of the polygon increases. Sides of polygon increases. If that happens, there we are, I can write it in. As that happens, well then the estimate for pi, so our estimate pi, well that just then becomes k times 1, and that's just going to give you k. So then the two things are going to be equal to each other, like so. So you can see what the mark scheme put here. Again, something along the lines of relative frequency approaches 1 or becomes 1. And I've mentioned this part here. Both of these actually, the area of the polygon and the circle basically become the same, or almost all the discs will land inside the circle because you don't have much of a rim on the outside of it to work it out. If you want to practice a bit more paper 6 work, because I understand these questions are tricky, and for many of you they are quite new, and you do need to get the practice on this, check out the playlist in front of you. That is all my paper 6 content. I've got loads of paper 6 content, so you can go through lots of practice questions and see the thinking that you need to succeed on this paper.